Hi guys, welcome back. Today we're going to look at geometric sequences. Hopefully we've already seen arithmetic sequences, but if not, we'll be doing some review in here. Let's take a look. We're going to identify and generate geometric sequences, which are very similar to exponential functions. So the second one, relate geometric sequences to exponential functions. So we'll see that today. All right, let's take a look at the vocab. Geometric sequence. In a geometric sequence, the first term is non-zero, and each term after the first is found by multiplying the previous term by a non-zero constant r called the common ratio. Common ratio, this is going to be very important, so we can underline that. You can find the common ratio by dividing any term by its previous term, also very important. So find the common ratio by dividing the any term by its previous term. So let's look at the first example here. It says to determine whether each sequence is arithmetic, geometric, or neither. So what you're going to want to do for these is you're going to want to find the difference between these things. So let's take a look at the difference between 256 and 128. Well, the difference between those is 128. What's the difference between 128 and 64? Well, it's 64. And what's the difference between 64 and 32? That's 32. So as you can see, arithmetic sequences, the differences here are going to be like plus 4, plus 4, plus 4. They're going to be the same, okay? And geometric sequences, when you take let's take the first term. So let's take, or the difference from the first term. Let's take 128. Divide it by 64, and we'll see what we get. So when you do that, you get 2. So this might be our common ratio. We just have to check the next differences. So let's check 64 divided by 32. That is also 2. So we now know that our common ratio is 2. And since we have a common ratio, that tells us that it's geometric. So this sequence is geometric. Sequence is geometric. So let's look at the next example. You're going to do the same process. We're going to do the difference between these two. The difference here is 5. The difference here is 3. And the difference here is 4. We know it's not arithmetic because they're not all the same. Let's check and see if it's geometric. So we'll take 5 divided by 3, and we'll have to check 3 divided by 4. And right away, I can tell that these things aren't going to be the same, right? 5/3 is bigger than 3/4. This gives you 0.75, and this gives you 1.6666 repeating, so not the same. So this one would be neither. So I guess we can circle these. So neither. All right, letter C. Difference here is 2. Difference here is 6, and the difference here is 18. Let's check our ratios. We're going to check 6 divided by 2. That gives us 3. And we're going to check 18 divided by 6. That also gives us 3. So our common ratio is 3. And then therefore we know that this is going to be geometric. Perfect. All right, now that we know how to determine if it's geometric or arithmetic, let's look at some examples where we have to find the next 3 terms in the geometric sequence. So it's already telling us that it's geometric. We just have to find the next 3 terms in the sequence. So what I like to do is I like to find the difference here. I like to find the common ratio first. So let's put find common ratio. So find the common ratio. So difference here, ignore the negatives for now, okay? So ignore the negatives. So this is going to be, we're going to say that the difference here is 3. The difference here is 12. And the difference here is 48. So let's take 12 over 3. I know that to be 4. And 48 over 12. I also know that to be 4. So common ratio is going to be 4. But keep in mind we have these negatives right here. So if you just plop a negative sign in front of there, that'll give you the common ratio here. So our common ratio is -4. So now we can find the next 4 terms in the sequence. So all we have to do is take this number, this -4, multiply it by the 64 in the next sequence. So this is going to be -4 times -64 is going to give us 256. If we multiply this by -4, we will get -1024. Multiply this by -4, and we get 4096. Find the next 3 terms. Boom, boom, boom. Next 3 terms. All right, let's look at the next one. Difference here would be 6. Difference here would be 3. And difference here would be 2/3. So we'll take 6. We'll take 3 divided by 6. And we get 1/2. And take 2/3 divided by 3. And what you find is that we also get, the difference here, let me redo this real quick. Even I make mistakes. The difference here is 2, right? So now let's do 2 divided by 6, we get 1/3, and 2/3 divided by 3, you also get 1/3. So our common ratio is going to be 1/3. All right, so common ratio is 1/3. So I just gotta take this and I gotta multiply it by the next term in the sequence. So 1/3 times 1/3 gives me 1/9. That's the first one. Now we take 1/9 times 1/3. And we get 1/27. It's the second one. And now we take 1/27 times 1/3. And we get 1/81. That's the fourth one. Or the third one, excuse me. All right, now let's look at the last one. The difference here is going to be 12. Difference here will be 60. Difference here is 300. Let's try and find that common ratio. So I'll take 60 divided by 12. Gives me 5. And 300 divided by 60 also gives me 5. And just remember, keep in mind these negatives here. So your common ratio for this one will be -5. So now you're going to take this -5 and you're going to multiply it by this 375 right here. So 375 times -5 gives us -1875. Multiply that by 5 and the next one would be 9375. And then this is 1, 2, and then the last one would be -46,875. I'm just multiplying those by -5. So times -5, times -5, and times -5 to get that last one. All right, I'm gonna pause it here and we'll do the back part in part 2.